For number 9 on the Pert practice test, I'm asked to factor completely again. And this is the difference of two perfect squares. So I'm asked to factor completely the binomial of x squared minus 4 over 25. So what I'm going to do is set up my parentheses template here and then figure out what times what equals x squared. So x times x equals x squared. Now what fraction times what fraction equals 4 over 25? And basically what you want to do is square root everything when you do a difference of perfect squares. If you square root x squared, you get x, and you double it down. So the square root of 4 is 2, and the square root of 25 is 5. So 2/5 times 2/5 can multiply together to equal 4 over 25. And it's a difference of two perfect squares, so the symbols are going to alternate plus minus. Let's see if that lines up with any of our choices. And yes, it does. Choice C from the Pert practice test for number 9. Number 10 on the Pert practice test, it asks me to factor. Pretty scary looking trinomial. I don't have just an a squared. I have a leading coefficient of 4. And then they throw a couple of extra letters in there. So what I'm going to look for in this case is a GCF. So I want to find out what the greatest common factor is for this trinomial. I usually look at the front number and the back letter, but that doesn't work in this case. 4 doesn't go evenly into each of those terms. So I have to figure out what goes evenly in the 4, 6, and 2. And 2 goes, the digit 2 goes into each of those evenly with no remainder or no decimal. Now I have to figure out what letter goes evenly into all of these. Notice there's not an A in each of these terms, but there is a K. So I can pull a K out of each of these. So I'm going to divide each term by K. So my GCF is going to be 2K. And I like doing this. This kind of breaks it down nicely. I follow down with the plus signs. And now I'm going to try to determine what my trinomial will be after I simplify it by pulling out the GCF. Well, 4 divided by 2, that gives me 2. K divided by K simplifies, and that just leaves me with 2a squared. 6 divided by 2, that leaves me 3. And then the K divided by K, that simplifies, and that leaves me with just a plain old 3a. And last I heard, 2K divided by 2K, anything divided by itself, is going to give me 1. I'm a little upset because I still have a leading coefficient, and they're not easy to factor. I'm going to use a method a friend of mine told me, and he calls it the Yiddish method. I used to have a method called the British method, but he came up with a little more compact method. So what I'm going to do is draw a circle in a box. I'm going to start talking a little bit quicker here. And in that circle, I'm going to put the B term, the middle term, from my factored trinomial. So I'm going to put a 3 in that circle. Now, what I need to put in that box is usually the back C, but because there's a leading coefficient, I have to rainbow this and put A times C, or 2, in that box. Now you have to figure out what times what multiplies to equal 2 that adds up to equal 3. And I believe it's 2 times 1 multiplies to equal 2 and adds up to equal 3. This moves along pretty quickly now. The trick is to just write down a 2a underneath the fraction bar twice, because I have to multiply them together somehow to get this trinomial. And then you take the factors that you figured out over here on the right and heap them on top of the 2a and 2a. So I put a 2 there and a 1 there. Now this one's plus plus, so that means my symbols are going to be plus plus for my factors. Now what you need to do is look to see if anything simplifies. And notice these 2's cancel out or simplify. So that's going to give me a 1 over a. Now when I set up my factors, this 2a with a 1 on top is going to be a factor of 2a plus 1. And this 1 over a is going to be a factor written down as a plus 1. Now I can't forget about my original 2k. That's out front. So let me see if I factored this completely, if any of these answers line up with my final answer. And there it is. If you're actually working this problem out, you might want to start eliminating stuff as soon as you pull that 2k out. But in this case, choice A lines up perfectly with my factored out solution.